All right, number 6. Determine the measures of the angles of turn symmetries. Remember, like turn symmetry, like how far you can rotate something to make it come right back onto itself? We only want angles less than 360 because, of course, any shape, if you turn it all the way around, it'll be back onto itself. We're not counting that. We're just counting angles less than 360. So what do you think about part A here, this figure? Can we rotate that figure like less than all the way around, like, and have it come back onto itself? If we, how about if we rotate it 180? If we flip it halfway around, like if this part goes down to there and this part goes up to there. I think so, huh? Yeah, that'll be back onto itself, won't it? Yeah, that it has 180-degree rotation symmetry, turn symmetry. Right? If you flip it halfway over, it'll look the same as it looked before, won't it? So symmetry means same, right? S-Y-M when in front of a word means same. So it'll look the same if you turn it 180 degrees. How about part B? How far can we rotate this shape over here? If this part goes to there, turn it a quarter turn, huh? It'll look the same. So that's how far? 90 degrees. But you could also take that part and turn it all the way down to there, which would be 180, and it'll look the same. Or what's the other one? Here all the way to there, which is 270. So this has 90, 180, and 270 turn symmetries, doesn't it? You can rotate that shape 90 degrees, 180 degrees, or 270 degrees, and it'll look the same. It'll be right back onto itself. Is that good there? Yeah.
Would it be a point symmetry? Would that be like 180?
All right, on to number 7. The ratio of the measures of two supplementary angles is 1 to 9. Find the measure of the angles. So how do we do that? Two supplementary angles is 1 to 9. So I'll bring it up here. We can say they're x and 9x. 1x and 9x, right? Something's 9 times as big as the other, right? The ratio is 1 to 9. One's 9 times as big as the other. Those are two ways of saying the same thing. 1x and 9x. And they're supplementary. What does that mean that they're supplementary? They add up to 180, exactly. They add up to 180. Yeah, 1x and 9x add up to 180. So you might want to put supplementary as 180, or you might know that so well you don't need it on your card. What is complementary? 90. Complementary makes 90. Supplementary makes 180. Make sure you know those. They'll certainly be on the test. So then we just solve that equation. How do we solve that equation? 1x and 9x? 10x. What do we do to solve for x? Divide by 10. X is 18. Okay, so what are the two angles then? Well, 1x and 9x, and now the mystery's over. We know what x is, so plug in x there, plug in x there. So 1 times 18 is 18. 9 times 18, what's that, 90? 162. So the two angles are 18, and 162. See how one of them is 9 times as big as the other? And they add to be 180. So I found it. I solved for x. And then once I got the answer for x, I plugged in x and plugged in x to the original formulas, 1x and 9x on that. So the ratio of two supplementary angles is 1. Oh, we just did that one, huh? Number 8, list all of the angles of rotational symmetry. All right, so what angles can we turn that figure, rotate that figure, so it'll come right back onto itself? So if we put a dot in the center here and we think about rotating it, kind of like this, huh? So how far does this need to rotate so it'll come back onto itself? Yeah, see how it's 1/3 of the way around? So what's all the way around? 360. And we're going to divide it by 3 because it's 1/3. It's 3 turns to go all the way around. So that's 120. So this must be a 120 rotation. But then you could do a second 120 rotation, couldn't you? In other words, you could go from here all the way to there. You could take this point to that point, and that would be back unto itself as well. So that's 120, 120. Bless you. That's 240. Does that make sense? And then you could do one more 120, but that's 360 if we never count 360. Anything can do 360. Right? So there it is. 120 and 240 are the two rotational symmetries. If you turn that shape 1/3 of the way around or 2/3 of the way around, it'll be back unto itself. 120 or 240. And then number 9, does this figure have point symmetry? Yeah, glad that you brought that up. Silvino, point symmetry. Point symmetry is the same as 180-degree rotation symmetry. That's basically what they're asking. Because what they're saying is hey, if you put a point in the center, does the whole shape like reflect across that point? That's what they're asking. And it's true, it does, if you could turn the thing 180 degrees and it'll look the same. It'll be back unto itself. So can we? If we take that diamond and we turn it halfway around, yeah, it's right back unto itself, isn't it? So yes, it has 180-degree rotation symmetry, which means yes, it has point symmetry. That's what point symmetry is. That means it's a reflection. The top reflects right through the point in the middle to the bottom. Everything, that point is the center. Everything reflects through that point in the center. It's the same all about that point. Point symmetry. Good there. So have that on your card. It's another point symmetry question. All right. Does that figure have point symmetry? So remember what point symmetry is. They're basically asking, does it have 180-degree rotation symmetry? So if you flip that one 180, will it be back unto itself? No. This point would go right to there, So it'd be like this, wouldn't it? If you did a 180, it would be like that. That's not right unto itself, right? It would be like this, So no. So that one's a no. That one does not have point symmetry because if you flipped it halfway around, it would not be back unto itself. It doesn't all reflect through that point. All right, and then on to 11. Does this figure, another one. So there's 2 more, 11 and 12. All right. Does 11 have point symmetry? Getting a lot of point symmetry here. Yeah, no, because 180, no. If you did a 180, it would be, the arrow would be going up, wouldn't it? So no, it wouldn't be back into itself. How about number 12? If you did a 180 on another point symmetry, is there a 180 on that one? Flip that one halfway around, will it be right back onto itself? Yeah, it will. Can you? That one's a little harder to picture. This part would go right down to there, wouldn't it? Can you kind of picture that if you flipped it halfway around? You can always take your paper and do it like an outline and then just turn your paper halfway around. You have scratch paper during the exam and just kind of flip it around. Or just grab your test. Yeah, just grab your test and flip it halfway around. See if it looks the same. It will. It'll be right back onto itself. Yeah, just rotate your test. So that one's a yes. That has point symmetry because it's got 180 rotation. So that point in the very center, everything reflects through that point. Number 13. In a regular polygon, the measure of each interior angle is 165. How many sides does the polygon have? Been a while since we've done these. So yeah, good thing to put on your 3x5 card. Let me show you. So this is number 13, interior 165. Yeah, let me go over here and remind you of the formula. Number 13. Remember regular polygon. Remember that little formula we derived? Inside angle equals n minus 2 times 180 over n. Remember that little formula? So have that in your 3x5 card. What did they say it was, 165? I already forgot. What was it? Yeah, 165. So they're saying it's 165. How many sides does it have? So that's tricky. So the angle is 165 degrees. What's in? They basically want to know what in is. What's the number of sides in that'll make it come out 165 degrees? Well, we have two options here. Number one, we can solve that equation for n using some algebra. And if you're really comfortable with algebra, feel free to do so. Second option, which may be easier, is just to guess. It won't take long. And you won't have to know a bunch of algebra. What I mean is, just start with 10. I don't know. Pop into 10, hit the buttons on your calculator. You have a good calculator with you that you're comfortable with, right? No cell phones on test day. Make sure you have your calculator. That's going to be 8 times 180 over 10, right? If I just plug in the 10 there, 10 minus 2 is 8, right? And I'm just going to hit the buttons and see. And that comes out 144. So that's too small. So I need to go a little bigger. So then I'll go, okay, maybe I'll try like 12. I'll make it 12 now. So this will become what? Well, here, I'll do it down here. 10, huh? 10 times 180 over 12. When I plug in a 12, 12 minus 2 is 10. So 180 times 10 divided by 12, 150. So that came out higher, but it's not high enough. I need to get to 165. So maybe you're not preferring this method now. Maybe 15. I'm going to go quite a bit higher. Let me try 15. So this will be what? 13 times 180 over 15 when I try plugging in the 15 minus 2 is 13. Oh, 156. I'm not getting there very fast. That's only 156. All right. So I need to go quite a bit higher. Maybe it's... This plan is seeming less desirable now. 15, maybe 18? My goodness, really? So I'm going to take forever to get there. All right, 24. So is that right? 22 times 180 divided by 24. Yeah, you're right. There it is. All right, let me show the algebra way then. All right, so in case you don't want to do that guessing, how do you solve it by algebra? Do you remember the algebra way? You got two equal fractions, you cross multiply. So you can guess. It just might take a minute. Put this over 1, diagonal, diagonal. Cross multiply. So this becomes 165 times n is n minus 2 times 180. That good? These two multiply, 165 times n, and a 1 times, 1 times 180, that doesn't change anything. That's still just 180. Diagonal, diagonal. Cross multiply. You've seen that before in your algebra days? So diagonal, diagonal. And then you've got to distribute this. And we get 180n minus 360. Now, you got to remember how to solve. What do you do when you have like the letter on both sides? You got the n on both sides? Yeah, subtract one of them. It doesn't really matter. I'm going to do the 180 actually, because that'll put the n on the left. That'll be a little more convenient. Minus 15n is minus 360. Last step now is divide by minus 15. And you'll get that. What was it, 24? Yeah, 24. So there's how you would do it with algebra if you don't want to just guess around on that. Is that good? Questions on? What I see is people will make this algebra mistake. Here's what I've seen. They'll go like this. Let me see if this is any help to you. People will go 165, back to this step right here. 180n minus 360. Back to this step. And they'll go like this. This is what I've seen over the years. They'll go, okay, they'll subtract the lower one, which is totally fine. This is fine to do, but sometimes messes people up. And they'll cancel, and they'll go, okay, this is 15n minus 360. And that's all right and good. There's nothing wrong with that. But I've noticed over the years, sometimes people will do that, and they'll kind of get stuck there. Because that canceled out on the left, they kind of freeze up, and they don't know what to do. So I don't want that to happen to you. So doing it this way is totally fine. It's just you have to keep a 0 there and an equals, and then just keep on going, and it'll all be good. It'll all work. That makes sense. Don't freeze up when one of the sides cancel. That's just 0. Go ahead and write 0 and keep the equal sign. I've noticed they don't write the 0, the equal sign vanishes, and they all of a sudden kind of freeze up. No, just keep put a 0, keep an equals, keep right on moving. What n wants to be alone, so now we just add the 360, right? To both sides. Boom, it's all good. Just keep right on moving. And this will be 15 in, this will be 360, and then just divide by the 15, and you've arrived. Same answer. So that's fine too. Just don't freeze up when one side vanishes. Just make it a 0, keep the equal sign, it's all good. Either way is totally good. Questions on that one? All right, that was number, what was it, 13? We have a lot to go here. And this is just part 1. All right, so we got that with the angle measures. Wait, where were we? I'm confused. Oh, there it is. We're done. So this is 24 sides. So number 14. Determine the measure of an angle whose measure is 29 times that of its complement. 29 times that of its complement. Now, what does that mean, complement? What do you do with two angles that are complementary? They had to be 90, huh? Remember that? So you let one of them be x and the other 90 minus x. Not x minus 90. That's the other mistake I see a lot. A lot of people remember the 90, but they get it backwards. Well, why is it 90 minus x instead of x minus 90? Well, give yourself if you're in the middle of an exam and you're like, I can't remember, is it 90 minus x or x minus 90? A lot of times that happens to me. I have a terrible memory, but I made it through math and science because it's not based on having a good memory. It's about being able to find logical truth on your own. So if I was in the middle of an exam and I didn't write on my card and I wasn't sure which, I would test it out. I would go, well, let me think for a second. What if my first angle was 20 and I knew they added to be 90? What would the other one be? Well, it'd be 70. And I would think, right, so how do you get 70? Oh, you put 90 minus 20. Oh, the 90 has to go in the front. And I would remember. Do you see how I test it out? But if you can grab that, you'll go a long way in math and science. That is so much of how you make it in math and science. You test things. You don't have to have this perfect memory. You just have to use little tests like that with numbers. We think so much better with numbers than we do with x's. So just put in real life numbers and you'll know, oh yeah. The 90, it's 90 minus, so the 90 has to go in the front. Okay, so the right formulas are x and 90 minus x. But best thing, just write it on your card. Just totally write it on your card. If they say two angles are complementary, you got x and 90 minus x. And then they're saying one of them is 29 times the other. So what do you do with that? You just pop a 29 in front of one of them. In other words, I'll just do it in the x. 29 times x is 90 minus x. Right? Because if one thing is 29 times as big as the other, that means if you multiply 1 by 29, it'll equal the other. Right? Does that make sense? One equals 29 times the other. Now, could you have put the 29 on the right side? Totally. That would work too. It's either way. I thought it'd be easier to put it on the x than on the 90 minus x. But it'll work either way. So now we just solve that little equation for x. How do we do that? Yeah, because you got x on opposite sides. So you know the trick. You add x, and that is 1x, really, to both sides. Cancels this out. 29x and 1x, 30x, equals 90. Last step. Divide by 30. So x is 3. Okay, great. X is 3. What do I do with that? That means x is 3. So I go back up here. X is 3. So the mystery's over. Now we know what x is. X is 3. So wherever you see x, plug in 3. Here also. So this one is 90 minus 3. It's what? 87. So 3 degrees and 87 degrees are the two angles. Does that make sense? You can test it on your calculator. One of them is 29 times the other. If you take 3 times 29, you'll get 87. And they add to be 90, don't they? They're complementary. Now, which one do they want in this question? The measure and angle, whose measure is 29 times? They want the bigger one, don't they? They want the one who's 29 times. Determine the measure of an angle that's 29 times. So they want the 87 degree one. It's 29 times. It's the one that's 29 times its complement. How are we doing? How about, is that good questions I can answer on that one? So you can put that whole example on your 3x5 card if you want. Part B, if two triangles of a triangle are complementary, what must the third angle be? So if you have a triangle, I'll scribble it somewhere over here maybe. If you have a triangle and two angles are what I would do is I would just make up numbers. So much of math, when I read some crazy sentence and it has X's or words I'm not sure about, I just make up numbers. So if you can get this and if you can pass this on to younger folks, it is so helpful to start thinking this way. So what I did with my own children as they took math and science is I would say just put in a number. What does that mean? See the truth, move from there. So I just say, well, I don't know, complementary. I know that means it had to be 90, so I don't know. Maybe this one's 60 and 30. It just helps me think, helps all of us think way better. I'll just say, I don't know, I'll stick in a couple angles that are complementary that had to be 90, right? That's what complementary means. So what does that mean about the third angle? Remember, every triangle holds 180, so, oh yeah, the third angle's got to be 90, huh? Make sense? See how much better we think with numbers than X's and words? Right? So just go, oh yeah, the other one has to be 90 because triangle total is 180. So the other one is 90. Let's move on. Find X in the figure. I'm going to have to kind of erase this stuff so we can see X. What are we going to do with that? How in the world are we going to find X in that crazy figure? X is that little angle in the corner there. This one right here. It's that angle opening. It's just one of many angles in that crazy polygon.
Don't we use the formula for the polygon?
Yeah, there's two ways you could do it. We had a formula. The total degrees is n minus 2 times 180.
We can also do the lines right.
To make triangles. That's where that formula came from. Exactly. That might be easier for you. Either way. Yeah, you can just say, start wherever you want. Just pick one point, any point, doesn't matter. And just start making triangles. Remember we learned, because we know every triangle holds 180. That's where we came up with the formula. Just start saying, well, how many triangles are there here? You got to go to all the other points except the two right next to you, you know. So how many triangles are in there? So there's, is it 5? 1, 2, 3, 4. Yeah, 5. 5 triangles, yeah. So it's 5 times 180 degrees. That's, is that 900? 900. 900 degrees total must be in that figure. Now, the formula would have given you the same answer. Remember, n is always the number of sides. So you could have used the formula. There's 1, 2, 3, 4, 5, 6, 7 sides. So you see if you plugged in 7 right there for n, 7 minus 2 would have been 5 times 180. Same thing, either way. So, okay, so great. So there's 900 degrees. So then we just add up all those angles and subtract from 900, don't we? Is that what it is? Yeah. Okay, so add up the angles. You know, all these 131, 120, 124, all these. What did you say the total was again? 767. Thank you. And then just subtract from 900, right? Because we know there's 900 degrees total, because we already figured out there were 5 triangles. What is that, 133? So that X angle must be 133 degrees. Is that good? So have what you need on your 3x5 card for that. Maybe just the n minus 2 times 180. Or just make triangles on that one. All right, this is the stuff about parallel lines. Yeah, good. I made it bigger here. Basically, they want us to find all those angles. So, again, on the actual exam that you take next week, I'm going to give you not like it'll be like one question. Like I'll give you this picture and I'll say, just find angle 5 for me. You know what I mean? That's what I say. The real exam will be the same, but much smaller. I'm not going to give you whatever it is, 11 parts. I'm just going to give, but same setup though, same picture, and I'll say just find angle 5 for me. So that's what I mean. If you master the practice exam, you'll ace the real exam because it's smaller. All right, so how do we go through and find all those angles? Good job. Yeah, 1 is got to be the same because they're diagonal, huh? Right? Because I see this line and this line. Yeah, they're called vertical angles. They're diagonal. Angles that are diagonally across are always equal, aren't they? So that's got to be 75. We can do the same thing down here, huh? This one's got to be 111 because those are diagonal. Good. It's a good start. What else can we do? 10. Which one's 10 and 1? So what you said, 10? Yeah. 10 and 1. Are they? Yeah, I think you're right. 10 and 1. They're alternate exterior angles. Good job. Good job. They are. That's always a little harder for me to see. But you're totally right. This and this have to be the same. Because you see how they both have 2 parallel lines cut by a transversal. And they're alternate exterior angles. Good job. It's easier for me. That's great. If you can see that, good job. I find it easier to see the Z angles. That's why I made up that saying for y'all. So let me go back and do that. Might be easier, but if you can see this one, you can do it all. But remember the Z? So here's what I like to do. I like to go Z right here. Remember that Z shape? So whenever you have top and bottom of parallel lines, make the Z, and the 2 angles, when you do a Z, there's 2 angles the Z makes, huh? Those 2 have to be equal. They're called alternate interior. They have to be equal. So I look and go, 79 is the same as which angle? Number 9. That's right. I was looking at the wrong one. Yeah. That's got to be 79 right there. And then I can go diagonal to get the other 79. Of course, we already had it because it was a good observation. Yeah, Nancy made, right? All right, so those are both 79. So, good. So now, where else can we go from here?
Did you say like the line makes...
Yeah, straight line, one side's 180, huh? Right, because, right, if you're, yeah, we can use that. We can find like this angle, right? That's what Danielle's hitting on? Yeah, totally. So just subtract from 180. This is going to be, what, 101? Because those 2 have to make 180. Remember, one side of a straight line always makes 180. Because, why is that? Well, because that's half a turn, right? Remember, all the way around is 360. And so halfway around must be 180. So that's what a straight line is. Half if you're going, if you're going down the street, headed one way, and you make a U-turn to go the other, you did a 180 halfway around, right? So yeah, one side of a straight line always holds 180 degrees. That's the opening of a straight line. Good. And then this has got to be 101 because they're diagonal. And 111, I can find this one because they got to make 180. What's that going to be? 69. Yeah, 69. And then this is 69 because they're diagonal. All right, now I just need to get up there. Is there something else I can do? Oh, the triangle. Yeah, good job. Good job. We can do the triangle. Because this is 79, 69. I can get angle 4 because they have to make 180. They're a little triangle in there. So we're using all these different facts. What's that going to be? 79 and 69. It's 148. So what does that leave? 32. That one's got to be 32 to make 180 inside that triangle. And then diagonal. This one's 32 because that's diagonal. And now we can do the 180, right? This line here, the top of that line has to be 180. So add the 32 and the 79. So add 111. What does that leave? 69. And this is diagonal 69. We got them all.
We could do the backwards Z.
Or we can do the backwards Z. Yeah, let's do that. That's a good observation then. That's right. Backwards Z works too. So where were you seeing the backwards Z? Right here. And where were you going? Which ones?
4, 5, and 7.
Yeah, totally. There and there. This has to be the same as this. Yeah, good. Yeah, that would probably be even easier. Don't have to mess with the triangle so much. Yep. That would have worked as well. Backwards z's have to, forward or backwards, the z angles are always equal, aren't they? That good? Other questions or comments on that? Kind of thing. Just all those facts about triangles 180, diagonal angles are equal, line, one side of a line is 180, and forward and backward z's. Danielle.
8 and 3 always be the same.
What are we doing? On to 17. All right, a whole bunch more of the same kind of thing. So I'll probably give you one of these, basically, on the exam. Some triangle setup thing. Okay, so let's do part A here. You have this? Yeah, part A. So can we find this angle here? Right, the 180, they got to make 180. So what is that, 48 degrees? So those, because these two make a straight line, they're one side of a straight line, so they got to make 180. Right, so I just subtracted 180 minus 132 there, got 48. And now can I find x? Triangle holds 180, right? So 48 and 57, what is that? 105, so this leaves 75. So x must be 75 on that one. How about part B? Oh, yeah, that's 90, 66. So what's that going to be? 24? Because they got to make 180. So x is 24. How about part C? Part C is a little more tricky. Yeah, let's do that one. What is this angle here going to be? 180 minus 2x. Right? Because together these guys are one side of a straight line. So they have to make 180. So that one inside is 180 minus 2x. Okay, well then what? Well then we say 180 minus 2x plus 62 plus x must make 180 total, right? These three must make 180 total because they're in a triangle. So now we have a little equation we can solve for x. Let's do it. So first, what should we do here? I'm going to subtract the 180 maybe from both sides. And it's just gonzo. So this would be minus 2x plus 62 plus x is 0. Minus 2x plus 1x is minus 1x. Is that good there? Minus 2x plus 1 is minus 1x. And then just subtract the 62 to the other side. Minus 1x is minus 62. Divide by the minus 1. X is 62. X is 62. So what do we do to find that little x up there?
The top of it is 90 degrees minus 66.
Oh, yeah. So this has got to be, what is it, 24?
Yeah, and then
To
you
make-
use the 90 and 24 to subtract this one.
Oh, yeah. 90 and 24. What's that? 114. So x is the leftover. So x is 180 minus 114. Is that 66? X is 66.